This is SpaceTime, Series 22, Episode 18. Coming up on SpaceTime. A new study finds Earth's outer atmosphere, the Geocorona, extends almost twice as far as the Moon. Evidence of a violent past around the planet Neptune. And NASA says it's all systems go for Crew Dragon to launch this weekend. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have discovered that a tenuous, gaseous, unseen outermost region of Earth's atmosphere, called the Geocorona, extends deep into space, almost twice as far as the orbit of the Moon. The new data is based on early observations by the joint NASA-European Space Agency Solar and Heliospheric Observatory spacecraft SOHO. The data shows this Geocorona not only wraps around the Earth, but it reaches up to some 630,000 kilometers away. That's some 50 times the diameter of the planet. The study's lead author Igor Balyukin from the Russian Space Research Institute says scientists weren't aware of the Geocorona's extent until they dusted off some observations made by SOHO over 2 decades ago. Where Earth's atmosphere merges into outer space, there's a cloud of hydrogen atoms called the Geocorona. SOHO's SWAN instrument used its sensitive detectors to trace the hydrogen signature and precisely measure just how far away the outskirts of the Geocorona are. These observations by SOHO could only be done at certain times of the year when both Earth and its Geocorona came into the spacecraft's field of view. For planets with hydrogen in their exospheres, water vapor is often seen closer to their surface. And that is the case for the Earth as well as Mars and Venus. And it's a characteristic that will be especially interesting when looking for planets beyond our solar system, planets with potential reservoirs of water, an essential ingredient for life as we know it. The first telescope on the surface of the Moon, placed there by the Apollo 16 crew in 1972, captured an evocative image of the Geocorona surrounding the Earth, glowing brightly in ultraviolet light. At that time, the astronauts on the lunar surface didn't know they were actually embedded in the outskirts of the Geocorona. The Sun interacts with hydrogen atoms through a specific wavelength of ultraviolet light called Lyman alpha, which atoms can both absorb and emit. And since this type of light is absorbed in Earth's atmosphere, it can only be observed from space. The new findings show that sunlight compresses hydrogen atoms in the Geocorona on Earth's day side, the side facing the Sun. And it also produces a region of enhanced density on the night side of the planet. The denser day-side region of hydrogen is still rather sparse, with just 70 atoms per cubic centimetre at 60,000 kilometres above the Earth's surface, and only about 0.2 atoms at the Moon's distance. There's also ultraviolet radiation associated with the Geocorona, as the hydrogen atoms scatter sunlight in all directions. However, it's all drowned out by the far greater flood of ultraviolet radiation coming from the Sun. On the downside, it means Earth's Geocorona could interfere with future astronomical observations performed in the vicinity of the Moon. Future space telescopes observing the sky in ultraviolet wavelengths, in order to study the chemical compositions of stars and galaxies, will need to take this into account. Launched way back in December 1995, SOHO has been studying the Sun from its deep core to its outer corona and solar wind for more than 2 decades. The satellite orbits in the Lagrange L1 position, some 1.5 million kilometres from the Earth towards the Sun. This is a point in space where the gravitational pull of the Earth and the Sun balance each other out, allowing a spacecraft at this location to remain stable in that position relative to both the Earth and the Sun, and travelling around the Sun as the Earth orbits it. The location's a good vantage point to observe the Geocorona from the outside. SOHO's SWAN instrument imaged Earth and its extended atmosphere on 3 occasions between 1996 and 1998. And these unique images of the whole Geocorona as seen from SOHO are now shedding new light on Earth's outer atmosphere. I'm Stuart Gary. You're listening to SpaceTime. Astronomers say a mysterious moon discovered orbiting the ice giant Neptune back in 2013 may be the result of a massive collision with a passing comet. After several years of analysis, astronomers using the Hubble Space Telescope believe it's the best hypothesis to explain this tiny moon, which they've named Hippocamp. What makes this moon so interesting is that it was found unusually close to the much larger Neptunian moon Proteus. The diminutive moon is only about 34 kilometres wide and only around 1,000th the mass of the 418 kilometre diameter Proteus. Hippocamp was found just 12,070 kilometres away from Proteus. Now, normally at that distance, a moon like Proteus would have either caused Hippocamp to break up and crash onto its surface, or if it was in the right gravitational position, it would have simply flung the small moon out of the Neptunian system. So the question begs, why does Hippocamp exist? Well, a report in the journal Nature suggests that Hippocamp could be a chipped-off bit of Proteus that was torn off in a collision with a comet billions of years ago. One of the study's authors, Mark Showalter from the SETI Institute, says the first thing he realised was that one normally wouldn't expect to find such a tiny moon right next to Neptune's biggest inner moon. He says that in the distant past, given the slow migration outwards of the larger moon, Proteus would have been where Hippocamp now is. This scenario is supported by Voyager 2 images from 1989. They show a massive impact crater on Proteus, almost large enough to have shattered the moon. Of course, back in 1989, scientists thought the crater was the end of the story. But now, with Hubble, they can hypothesize that a little piece of Proteus got left behind, and it's seen today as the tiny moon Hippocamp. It all adds to a growing picture of Neptune's satellite system as a place with a violent and tortured history. Many billions of years ago, Neptune captured its giant moon Triton from the Kuiper Belt, a large region of comets, frozen debris and icy objects circling the Sun out beyond the orbit of Neptune. Triton's gravity would have torn up Neptune's original satellite system. As Triton settled into a circular orbit, the debris from shattered Neptunian moons would have recoalesced into a second generation of natural satellites. However, comet bombardment continued to tear things up, eventually leading to the birth of Hippocamp, which might be considered a third-generation moon. Based on estimates of cometary populations, astronomers know that other moons in the outer solar system were hit by comets, smashed apart, and then reaccreted multiple times. Oh, and that name Hippocamp? Well, the rules of the International Astronomical Union require that the moons of Neptune be named after Greek and Roman mythology of the undersea world. In Greek mythology, Hippocamp was a creature half horse and half fish. By the way, the scientific name for the seahorse is Hippocampus, as of course is the name of an important part of the human brain. I'm Stuart Gary. This is SpaceTime. A harpoon, designed to clean up hundreds of thousands of bits of space junk now orbiting the Earth, has just passed a key test, successfully spearing a piece of simulated space debris. It was the second of 3 tests for the refrigerator-sized European Removed Debris satellite. The test involved the firing of a tethered barbed titanium spear, about the size of a pencil, at around 80 kilometers an hour at a target attached to the satellite by a short boom. The harpoon slammed into the aluminum panel and held fast just as planned. In an actual cleanup mission, the satellite would use a much larger space harpoon to snare debris, and then drag it down into the atmosphere, where the entire assemblage would harmlessly burn up on re-entry. The United States Strategic Space Command is currently tracking around 18,000 artificial objects in orbit above the Earth. Of these, only around 1,500 are operational satellites. The rest are disused spacecraft and spent rocket stages. But these are only the objects large enough to be tracked from the ground. Current estimates suggest there are well over 700,000 bits of space junk a centimetre or larger in size. And if that's not staggering enough, current estimates suggest there are some 170 million bits of space debris a centimetre or smaller in size currently orbiting the Earth. And the thing to remember is that all these objects are travelling at orbital speed, 28,000 kilometres per hour or faster. One of the big fears is something called a cascade event, where bits of space junk slam into satellites creating more debris, which then slams into other satellites creating even more debris, and so on. It's a scenario depicted accurately in the opening scenes of the movie Gravity. It's about the only thing in the movie that was accurate. The Remove Debris satellite is testing a number of different methods to get space junk out of space. Last September, it successfully used a spring-loaded net to capture a piece of mock space debris. And in the next few weeks, the spacecraft will attach an inflatable drag sail to another piece of debris. The drag sail is designed to collide with the rarefied atmosphere at the satellite's altitude, causing orbital decay and the eventual re-entry and burn-up of the satellite and debris. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Now, Fred, we're going to revisit something we've discussed before, and this is the problem of space junk. There's so much garbage out there that we've put into space that it's reaching a point where they're starting to worry about, the assets orbiting Earth that are working, communications satellites, for instance. So they've been trying to figure out ways to clean up the mess. And one of the ways that was being touted was using harpoons. Well, the good news is they've done a test.
This is all about the spacecraft, which has the slightly self-explanatory name of Remove Debris.
Yeah, that's just, I mean, they took several months with massive committees to come down to that. I mean, that can only have been figured out by a committee.
Yes, that's probably true. It's probably a terribly eminent committee as well. So
probably. Sorry.
Remove Debris, product of a group in the UK led by the University of Surrey. And its mission was to test out different technologies for attempting to clear the Earth's environment of all the debris that's hanging around up there. So Remove Debris is a good name for it.
I think they should, I would have thought, Eliminator 1 or something like that. Give it a ballsy name. Give it something to...
Clean Up 53. How's that?
That's nearly as bad, Fred.
It is, yeah. So this thing was launched from the International Space Station, actually. It went up on one of the transit spacecraft. It was launched from the International Space Station, if I remember rightly, it was around about this time last year. Don't quote me on that. And one of the tests that was done was to use a net to grab onto bits of passing space junk, because the net is self-closing and is also attached by a tether. You can then use that to deorbit the piece of space junk. So the real step that has to be taken with this stuff, and by the way, there are somewhere between 7,500 and 8,000 tons of debris up in space, ranging from the tiniest little pieces to huge rocket bodies that are spent. So the main aim is to take that bit of space junk and slow it down, because slowing it down brings it down nearer to the upper layers of the Earth's atmosphere, which slow it down further, and it undergoes this fairly catastrophic dive into the atmosphere, which almost always results in it burning up, basically evaporating in the atmosphere. Once in a while, if there's a large object, you can get some debris which makes it down to the ground. Nobody's ever been hit by any of this stuff yet, but it's always a possibility. But it's actually quite rare. And in fact, for the larger bits, the bits that are harmful, they are tracked by radar. So people kind of have a fairly good idea where they're going to come down. You might remember Tiangong-1, the big Chinese space station, which came down last year. And towards the end of its descent, even though it was out of control, people had a pretty good idea where it was going to land. And actually, it landed right where you would have put it if you'd had any control over it.
Oh, wow.
It's a region in the South Pacific Ocean.
Same with Skylab.
Yes, that's right.
Skylab, bits of Skylab in the Indian Ocean.
Yeah, bits of it came down in Western Australia as well.
Yeah, but Western Australia,
Careful. There's a big radio telescope there.
No, what I was going to say is it's a very remote country. So if you got hit by something in Western Australia, it's very sparse. You'd be the most unlucky person in the world, I reckon.
You would actually. That's right. And of course, it's that sparseness that makes it a good place to do radio astronomy from.
Yes,
giving a plug there for the square kilometre array. The aim is to slow things down. And so if you can attach some sort of, almost like a parachute, a kind of membrane to a spacecraft, what it does is it increases its cross-section, which means that the thin atmosphere that there is up there has a much greater effect in slowing down the spacecraft. So the two ways that have been tested with the Remove Debris spacecraft at the moment are, first of all, the net, but now the more recent one, which is the harpoon. So this is great stuff. You fire a harpoon at your target satellite, and it's got barbs on the end, spring-loaded barbs, that because there's enough weight in the harpoon to penetrate penetrate the titanium or aluminium shell or whatever it is of this spacecraft, the barbs open up, and then you've got a really good hold of it. And if the other end of the harpoon cable is attached to something like a membrane or a parachute, then that is going to have the desired effect in slowing it down. And that was the purpose of the test, to show whether you can actually harpoon something up in space without basically destroying your own orbit by the recoil. The trial seems to have gone flawlessly. All the reports I've read are glowing about the performance of the harpoon, so maybe that's a technology that would be worth developing.
Oh, much cooler too.
It's cool, really. Cooler than a net, yeah.
Definitely. But I just think it's really interesting that they're using fishing methods to
well,
catch
that's right. It's the same problem.
Yeah.
You know, it is the same problem. I have to say, I'd much rather see harpoons used on spacecraft than on whales. Indeed. And so, you know, it's very good use of old technology. There is one final experiment to be done by removed debris, which will be done probably within the next couple of months. And that is to deploy a device exactly like I've been talking about, a parachute or a kind of membrane, a solar sail that will actually bring removed debris itself back down to Earth. So they're going to try out the ultimate method of deorbiting it on the spacecraft that's doing the tests.
Well, that answered my question, because I was going to say, is removed debris ultimately going to become debris?
Well, it already is. But, well, actually, it's not. It's still got useful experiments to do. But that's right. If that step hadn't been taken, then it would become space junk itself. But it's not going to be done like that. So its height is roughly 400 kilometers. That's above most of the Earth's atmosphere. You know, you're well above most of it. But there is still enough up there in terms of the really rather thin layer of air that exists at that height to act as a brake on these deorbiting objects.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. NASA has approved the first test flight for SpaceX's new Crew Dragon 2 capsule for this weekend. The Crew Dragon will eventually signal the return of America launching people into orbit from American soil, something that hasn't happened since the mothballing of the Space Shuttle fleet back in July 2011 with the return to Earth of the Space Shuttle Atlantis on STS-135. Since that historic mission, NASA's been forced to buy rides to the International Space Station from the Russians, flying aboard Soyuz rockets out of the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The go-ahead for the March 2nd Unmanned Orbital Certification Test Flight, known as Demo 1, follows a flight readiness review. Backup launch dates will be on March the 5th, the 8th and the 9th. The flight will launch aboard a Falcon 9 rocket off Pad 39A at the Kennedy Space Center at the Cape Canaveral Air Force Station in Florida. That's the same launch pad which sent Apollo 11 to the Moon 50 years ago. The mission will test all flight systems, allowing mission managers to check out both ground and space-based systems, providing the data needed to achieve human spaceflight qualification for transporting crew to the space station. Life support systems will be monitored throughout the test flight. Data collection will be aided by a spacesuit-clad sensor-laden dummy that will fly the mission, a twin for Mannequin Skywalker, the one that flew aboard SpaceX's Falcon Heavy test flight, seated in Elon Musk's Little Red Coupe almost exactly a year ago. The flight plan calls for the Crew Dragon to fly to the International Space Station, test orbital approach and automated docking procedures, and undertake a full automated docking. One of the key concerns, especially from the Russian Federal Space Agency Roscosmos, is the reliability of the new spacecraft's computer guidance system. European, Japanese and Russian spacecraft all rendezvous with the space station using at least 2 independent autonomous systems that can abort an approach in the event that a computer glitch places the capsule on an impacting trajectory. However, Crew Dragon will instead employ redundancy in the primary computer system. The original Dragon used a non-autonomous manual docking system, requiring the space station crew to literally grab the capsule using the robotic Canadarm2 and then manually maneuver it into a docking port. Once berthed, the space station crew will then open hatches and inspect the new spacecraft to see how its systems have handled the flight. The current plan will see Crew Dragon undocking from the orbiting outpost and departing on March the 8th, before deorbiting and conducting a full re-entry sequence, splashing down in the North Atlantic Ocean about 370 kilometers east of Cape Canaveral. SpaceX crews waiting near the splashdown point will then sail to the landing zone, load the capsule aboard a recovery vessel, and then return it to Port Canaveral for inspection. SpaceX says the same capsule will then be reused in April for a high-altitude in-flight abort test, although there's a bit of confusion because NASA had planned the test for June. If all goes well, the first human crew will fly aboard the new spacecraft on a test flight to the space station in July, with regular crew transfer operations then beginning before the end of the year. The Crew Dragon 2 capsule is based on the design of the original Dragon capsule used for cargo transport. That was always designed to eventually carry crew. A purely astronaut-carrying version, originally called Dragon 2, now called Crew Dragon, has been under development since 2014 as part of NASA's Commercial Crew program to use contractors to fly crew to the space station. Crew Dragon uses a new updated outer molding and is fitted with new flight computers and avionics, a full life support system, and room for up to 7 crew members. Instead of massive banks of controls, dials, switches and video screens, pilots will instead fly Crew Dragon using a touchscreen console, very Star Trek Next Generation. The original Dragon cargo ship used 18 Draco hypergolic liquid-fueled thrusters using a storable propellant mixture of monomethylhydrazine fuel and nitrogen tetroxide oxidizer. The engines combined the functions of both main propulsive thrusters and a reaction control system for attitude control and maneuvering. The new Crew Dragon will use 16 of these Draco thrusters fitted in each of 4 side-mounted pods. But Crew Dragon's also fitted with 8 Super Draco rocket engines, 2 fitted in each of the 4 thruster pods. Each Super Draco is about 200 times larger and more powerful than the original Draco RCS thrusters. These will be used as a launch escape system to fly the capsule out of harm's way during a launch or ascent emergency, as well as for orbital maneuvers. Originally, they were also going to be used for propulsive landings without any need of parachutes, but that's been put on the back burner for now in favour of a conventional parachute splashdown at sea. Unlike the original Dragon cargo ship, which uses deployable solar arrays that are extended once in orbit, Crew Dragon uses solar panels mounted directly on the sides of the service module. The service module, which is called a trunk by SpaceX, also houses auxiliary equipment and heat removal radiators, and it provides aerodynamic stability during emergency aborts. The new spacecraft also uses a movable blast shield, which allows more precise attitude control of the spacecraft during the atmospheric entry phase of the return to Earth. As well as Crew Dragon, a new Cargo Dragon variant, carrying 3,370 kilograms of supplies, will also be produced, replacing the current Dragon cargo ship. Cargo Dragon will use 16 Draco thrusters, 4 of which will be fitted to each of the 4 side-mounted pods. The use of the hypergolic fuels means both Crew and Cargo Dragons will be able to remain docked to the space station for up to 210 days. Meanwhile, a second independent space station crew transfer vehicle called the CST-100 Starliner is currently being developed by Boeing. It's expected to undertake its first flight aboard an Atlas V rocket next month, with Starliner's first manned spaceflight slated for later in the year. I'm Stuart Gary. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that methane levels in the atmosphere have been rising since 2007 and are not slowing down. A report in the journal Global Biogeochemical Cycles says methane emissions were dropping at the start of the 21st century, but new air sampling data shows they've been ramping up, especially in the years 2014 to 2017, at rates not seen since the 1980s. The discovery is important because methane is a far more efficient greenhouse gas than carbon dioxide. Furthermore, the increase in methane was unexpected, and so it wasn't included in climate change predictions used in the Paris agreements. Bit of good news now, and researchers have used liquid metals to turn carbon dioxide back into solid coal. The research, reported in the journal Nature Communications, could transform science and industry's approach to carbon capture and storage. A side benefit of the process is that the carbon can hold electrical charge, becoming a supercapacitor, so it could potentially be used as a component in future vehicles. Medical science has long known that eating too much, especially proteins, reduces lifespan. And now they've finally worked out why. A report in the journal Current Biology demonstrates that increased nutrient levels speeds up protein synthesis within cells. And the faster this process occurs, the more errors are made. It's similar to everyday activities like driving. The faster you go, the more likely you are to make a mistake. The resulting buildup of faulty proteins within cells then compromises health and reduces lifespan. The findings also reinforce established links between low-protein, high-carbohydrate diets and longer, healthier lives, especially when it comes to brain health. The thing is, carbohydrates get a lot of bad press, especially in relation to dieting, but eating high-fiber carbohydrates, like those found in fruit, vegetables and unprocessed grains and seeds, will produce healthy benefits. Samsung has announced that its new foldable phone, appropriately called the Galaxy Fold, will be launched on April the 26th in the United States and May the 3rd in Europe. Of course, we know it should have been May the 4th. Be with you. And of course, there will be a 5G version available. But these new phones won't be cheap, with prices starting around $2,000. Foldable cell phones aren't new. Chinese maker Royoli launched its foldable Flex Pi months ago. But Samsung is the first of the really big global players, with both LG and Huawei about to follow. The new phone uses Samsung's 7.3-inch Infinity Flex display, first revealed last November. It provides a tablet-sized screen, which can then be folded into a regular 4.6-inch display. There's 512 gigabytes of universal flash memory, alongside a Qualcomm 7nm octa-core processor and 12 gigabytes of RAM. And with all that extra screen real estate, the Android operating system used by the new phone lets you run 3 apps side by side. The Fold features a triple rear camera system that works in both phone and tablet modes. It includes a 16-megapixel ultra-wide camera alongside 12-megapixel wide-angle and telephoto cameras. There's also a 10-megapixel cover camera for selfies. Paleontologists have discovered a new species of a small theropod dinosaur which foreshadowed the rise of Tyrannosaurus rex. The newly discovered diminutive relative of the tyrant lizard king reveals crucial new information about exactly when and how T-Rex came to rule the North American roost. The new discovery, called Moros intrepidus, was just 1.2 meters long and weighed about 78 kilograms. It lived around 96 million years ago in the lush river-lined environment of what is now Utah. The tiny tyrannosaur, whose name means harbinger of doom, is the oldest Cretaceous tyrannosaur species yet discovered in North America, narrowing a 70 million year gap in the fossil record of tyrant dinosaurs on the continent. The discovery, reported in the journal Communications Biology, shows how early tyrannosaurs hunted in the shadows of the allosaurs, the established top predator of the day. Yet by around 81 million years ago, the North American tyrannosaurs had grown to become the iconic apex predators we all know and love, reaching lengths of almost 13 meters and weights of up to 14 tons. Well, it's not a cure for baldness. Anti-aging treatments are also guaranteed tabloid clickbait. Now, a new report claims a Japanese plant, commonly found in herb gardens, might actually hold a real clue to the secret of anti-aging. The study, reported in the journal Nature Communications, is based on research investigating a compound known as 4,4-dimethylocichalcone, or DMC, which is found in the leaves and stalks of the Eshitaba plant. Researchers found that it helped protect cells and delayed aging in yeast, mice, flies, and even human cells. The Ashitaba plant is a relative of the carrot family and is used in Japan both for food and as a traditional medicine. There's a new warning out today that worldwide measles cases increased more than 30% last year compared to 2016. The figures released by the World Health Organization show that more than 6.7 million people, mostly young children, caught measles last year, with 110,000 dying from the virus. In Europe, the worrying trend is being blamed on false claims by anti-vaxxers, wrongly linking measles vaccine to autism. Meanwhile, conflict and unrest are being blamed for increases in countries like Pakistan and Nigeria. While in Latin America, the increase is being blamed on the collapsing health system, especially in places like Venezuela, due to crippling political and economic crisis. Tim Mendham from Australian Skeptics says the World Health Organization guidelines show preventing measles outbreaks requires a 95% coverage for the first dose of the vaccine. But he says global coverage has stalled at 85% for several years, with the figure even lower in poor regions like Africa, where the coverage rate is just 70%.
This is really scary stuff. I mean, it's a major increase in measles cases around the world. So there seems to be a real boom in the anti-vaccination, the impact of the anti-vaccination. Way back when Andrew Wakefield did his report on supposedly autism linked to the MMR vaccine, and people got very worried in the UK, measles vaccination dropped and cases of measles soared. And then that seemed to die out a bit when there was proof that Andrew Wakefield was shonky. Since then, the measles has come back. The danger is that people do not see measles anymore. When I was a kid, a lot of people had measles. A lot of people got seriously damaged by measles. A lot of people used to die of measles. But then because through vaccination it died out, and suddenly people have become complacent, and it's come back again. And it's come back with a vengeance. In Europe especially, but in the US and increasingly in Australia, the numbers of cases of measles has increased. Measles at its height was killing about 2.5 million people a year, a lot of it in third world countries. That dropped in about 2016, I think it was, to about 80,000 a year dying. We're talking about not people who were medically damaged by it, they used to have encephalitis, all sorts of things, but killed by measles was dropped to 90. It's now back up to about 120,000 a year. People dying of this disease that we almost had wiped out, except the anti-vaccination movement kept making comments that, measles never killed anybody. You can have measles parties where you can bring your kids along and they can all catch measles and it'll all be great for them. Total stupidity, total irresponsibility. People are paying with their lives, and it's little kids, by and large, who are paying this price because their parents are not doing the right thing.
That's Tim Mendham from Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.